Hmm. Hello. Uh, okay, so um, what I want to talk about today is three things. The first two are kind of related, but so the first one is uh, Berkeley's explanation of natural science and mathematics. That is Berkeley's explanation of what kind of general knowledge we can have about sensible things, how we should look for that kind of knowledge and what it's good for. Um, and the second one is, as I said, is related because it's about mathematics. Huh, is that many eyes? Okay. The infinite divisibility of space. Um, or more specifically, Berkeley's argument against the infinite divisibility of space. Um, and the third thing is the refutation of skepticism. Yeah, there's a bunch of other things that would be worth talking about in this reading, plus there's stuff I wanted to say last time that I didn't get to. But since this is the last lecture on Berkeley and I don't want it to spill over into Hume, I'm just going to hopefully be able to get all through three of those and nothing else. Okay. Um, so the first one is this one, natural science and mathematics. Um, so um, according to Berkeley, uh, natural science and mathematics are both about observed regularities of in the sequence of sensible ideas. Um, that is, as I was saying last time, their syntax, the rules by which different sensible ideas are associated with others. Um, and the way that works, generally speaking, is that, here's the divine will. The divine will rule wills a certain regularity, a certain syntactic regularity in the ideas of sense. So this is divine will. This is my mind, or in general, any finite mind. So the ideas of sense are the ones that are not caused by my will, but by the divine will. And they have a certain regularity, which is due to the divine will. Um, and then when I learn general truths about them, so this is just like an overview of what Berkeley is going to say about both of these put together. When I learn general truths about these ideas of sense, that is about what we would usually call material things, um, uh, that means that uh, I establish my own signs for them, right? Remember, I don't have general ideas, but I do have general signs. So when I get general knowledge about these regularities, that means that somehow I'm adopting some things as general signs of the sensible ideas. And what it means to adopt them as general signs is to establish a certain syntax for them by my own will, right? Like remember the explanation of how variables work in algebra and whatever, that, I determine that I'm going to use this sign according to certain rules, which um, are supposed to allow it in the end to be uh, cashed out, so to speak, into the expectation of another sensible idea that's going to come in. And so the point is to get my rules for these general signs to uh, track the regularities that are willed by the divine will, so that if I just manipulate my signs, and then at the end I get out my expectation for what I'm going to see, my rules will have, right? So here's like, right, my general signs, which can be general words, but also when I'm doing geometry, that could be like a picture of a triangle, right? Remember, Berkeley says that works the same way. It's a general sign for every triangle as I use it in the demonstration. So these are my general signs. There's certain rules between them that are due to my will. And the point, what I'm trying to achieve by willing these regularities, is that, I can kind of like exchange one of these sensible signs for one of my general signs, manipulate my general signs according to my rules, and in the end, get out a prediction about what sensible idea is going to come next. Um, right? So, like, I see I see myself releasing this body in midair. I quickly exchange that for for general signs like a body released without support. I manipulate it according to my rules to get out the general sentence, the body falls. And then I exchange that back, so to speak, for a prediction that this body that I saw being released, I'm now going to see falling. And if I've done my general signs right, um, I'll get the right result out in the end. Of course, I mean, in that case, there really isn't time to do a lot of manipulation between letting go of the body and seeing it fall. But that's the general idea. Um, Okay, so, and what this shows, or is an example of, or is the most extreme example of, is a relationship between two doctrines. Um, One of them is empiricism, which, of course, this whole course is supposed to be about empiricism, and the other is voluntarism. And this is a connection that I didn't notice myself. I saw this. I think I saw this first in a book by Charles Taylor, but um, it seems very right. So I'm going to tell you about it now. Um, so voluntarism is the view that the divine will is prior to the divine intellect, or something along those lines, or in other words, that um, in some sense, God doesn't do things because God sees a reason to do them. Um, and that makes it, well, because God sees reasons that makes it necessary for them to happen. Does the divine will control someone like mind control? Oh, someone asked me that privately, but I can answer it. Someone asked me, does the divine will control someone like mind control? Well, it controls what sensible ideas I have. Um, so it doesn't, at least Berkeley doesn't say that it does, and it's a little hard to know how Berkeley can even talk about this. But so, I mean, I guess, the question you might want to ask is, oh, but does it control this? Does it control my will? Or does it only control the ideas that are in me that don't depend on my will? Which, that's not very much of mind control, controlling the sensible ideas that are in someone against their will, right? Like that's the same kind of way I can control your mind by showing you something. I force you to see it, so to speak, right? Now, I mean, according to Berkeley, that always only works by the intervention of God, actually, right? But so, I mean, so this much is not very much like mind control, although it technically is causing something to happen in my mind. But the question of whether God can control this is a question about like how a spirit can cause another spirit. And it's not clear how we can even talk about that, according to Berkeley, since we can't cause other spirits. Um, so the answer is I'm not, in a, in a stronger sense of mind control, I'm not sure what to say. Okay, so anyway, getting back to this, I was trying to kind of half-assedly explain what voluntarism is. Um, but yeah, I mean, it's basically saying there isn't some rule that God is following and that God adjusts his will to, like the rule of the divine intellect or understanding. Rather, the whatever rules there are for any intellect or understanding emerge from the divine will. So, I mean, this can mean different things depending on how extreme a version of it is. I mean, it could mean that the only reason contradictions can't be true is because God doesn't want them to be true. Sometimes it's thought that that's Descartes' position, although I don't think that's probably right. But anyway, um, but I guess, I mean, here I'm talking about voluntarism maybe in a more restricted sense. Um, uh, I guess the question being, um, are the regularities in nature due to the nature of things that God has created, or are they just due to what God thought it was convenient to have happen next? Um, and so, just without getting into Berkeley yet, I think you can see why there can be a kind of connection between these two things, right? Like, if you're a voluntarist, that means that, like, in a sense, everything that happens is a miracle. Um, uh, that is, everything that happens is due to the will of God. So there really isn't any way of predicting in advance what could happen. You have to wait to see what happens. So in particular, you can't somehow use your reason to figure out, for example, what bodies could possibly do. How could they act on each other, or something like that. Um, you just have to look and see what God wanted them to do. So, so I guess you could say, I mean, the connection goes this way from voluntarism to empiricism. Although more generally, I guess you could say they go together well, right? Um, so whereas rationalists who think that, like for example, Leibniz thinks that I can um, uh, Descartes and Leibniz think that I can know by using my reason what it is bodies could naturally do or not. So I can know that they only can affect each other by pushing. And Locke is close enough to their position, and it has to do with these visible necessary connections between ideas that Locke also thinks something like that. Um, so whereas Berkeley is going to say, like, no, there's no way I could know in advance that when one body strikes another, they don't go through each other or um, bounce off in completely different directions than they started in or whatever. I just have to wait and see what God wanted to happen in that case. Um, okay, so and then, I mean, as Taylor also points out, however, this may be unstable, and we'll see this to some extent in Hume, although we're not probably this quarter. I have not assigned the book by Hume that we'd really have to read, which is the Dialogues Concerning Natural Religion, but that this is kind of unstable because at a certain point, empiricists may realize that you don't need this part. That if all you know is what you wait to have happen, then you have no reason to add something else that it depends on. Just wait and see what happens, basically, right? So although empiricism for someone like Berkeley is, in a sense, like a super theistic position, right? It's a position that everything that happens depends directly on the will of God. It's a short step from there to atheism. Because all you have to do is say it doesn't depend on anything. um, okay. All right. I mean, there's more to be said about that. One of the things I didn't write about that I'm going to talk about today is Berkeley's refutation of atheism. Um, I mean, it has something to do with the supposed absurdity of ideas happening without a cause. It's supposed to be just as absurd as ideas existing without a substance to inhere in. Um, but we will see Hume uh, attacking that pretty strongly. Okay, so anyway, getting back to the specific content of these views in Berkeley. So switch to the document camera. So he says in part 1, section 1, section 31, on page 34. I mean, in the beginning of section 31, he talks about how the regularities that God wills are what allow us to a certain extent to predict what's going to happen in the future by formulating general rules, which I just said what that actually comes to, according to Berkeley. But then he says, all this we know, not by discovering any necessary connection between our ideas, right? So right there is where he's disagreeing with that point where Locke, I guess you could say, is not as strictly speaking empiricist as you might expect, right? In Locke saying that there's a visible necessary connection between ideas. So he says, right, which means that according to Locke, even though he's an empiricist, a strict empiricist in the sense that he thinks all our ideas come from experience, there's certain relations between ideas. So certain propositions that we can know hold, that is, certain propositions we can know to be true without experiencing that relation. So we got the two ideas, let's say, separately from experience, but now without any more experience, we know some connection there has to be between them, right? So, and that's what Berkeley is denying, right? So all this we know, not by discovering any necessary connection between our ideas, but only by the observation of the settled laws of nature. Um, so, that is, um, we come to be able to make this prediction by understanding why things happen in a certain way, but only in a particular kind of weak sense of why. And the weak sense of why is what Berkeley describes in section 62 on page 47. Um, he admits that natural science and mathematics can explain what happens, can explain various phenomena, but he says, which explication consists only in showing the conformity any particular phenomenon has to the general laws of nature. Or, which is the same thing, in discovering the uniformity there is in that production of natural effects. Right, so this is what's known as the what that is became known in the 20th century as the covering law account of explanation. It means that when you explain some particular thing, proposition P, you explain why it's true. That just means that you show that it's a consequence of some general law, and that general law then counts as its explanation. Um, right? So it's like, that's not really readable, is it? Right? We say that a universal generalization, let me not call this P actually, no, I should call it P. We say that an explanation of why phi, the property phi holds of A, is like a general statement about why the property phi, that the property phi always holds. Now, of course, the laws of nature don't never have the simple form like this, in the sense that they never say like everything is red or something like that, right? That wouldn't be a useful law of nature. So it's actually, I mean, it's something more like this. Right? We got a general law that says if phi holds of x, then psi holds of x. We notice that phi holds of a, so the particularization of this then says that if phi holds of a, psi holds of a, and we conclude that psi holds of a, and we've explained why psi holds of a, right? So like if phi is a body released without support, and psi is falls, right? So this says whatever is a body released without support falls. This says something A is a body released without support, and this says A falls. So now we have an explanation why A fell, namely this general law. So that's the kind of explanation that Berkeley thinks we can get. Um, it the explanation is only a good explanation as long as this law holds up, right? So if tomorrow I find something such that phi of that thing, but not psi of that thing, then it turns out that this law wasn't true, and so it didn't explain anything, basically, right? So this type of explanation um, 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 this type of explanation doesn't really give us a license to predict anything. Or, I mean, it gives us a license to predict anything only insofar as we believe that regularities on the whole will tend to continue, something like that. Um, whereas you might think there would be a stronger kind of explanation where you could explain why this was true by showing that if this is true, then there's a visible necessary connection between this and this. Right? So that would mean that, you wouldn't really have to wait to see that. I mean, I guess you could still write the rule this way, but now this would mean something else. This implication sign would mean that, like, you can see it's self-evident that whatever is like this has to be like that. And so you don't even have to test the rule once. You can start using it for predictions right away without having observed that it ever held, because you see the necessary connection just by looking at the ideas that are involved. So rationalists believe that we have some of those stronger kinds of explanations. There's some worries around the edge here about whether about God being able to make exceptions for miracles or something like that. But basically, rationalists hold that we do have this kind of explanation, and moreover, they think only this kind of explanation counts as an explanation at all, which, I mean, you could see why, if we did have this kind, we might want to say that, right? Like, if you say, I think this was because of this, but you can't see any necessary connection between the two, then what are you even talking about, is what a rationalist will say. Right? Like, if you meant because, you would have to mean that you see the necessity. See that you right that the necessity is self-evident to reason, or something like that. I mean, in particular, the rationalists will think that it follows from the nature of this idea, its definition, so to speak, that this one that this relationship has to hold. So in a way, Berkeley agrees with the rationalist that the kind of explanation he thinks we can have isn't really an explanation, and that the stronger thing that the rationalist thinks we should have is what an explanation would really be. So, right, if we go back of a document camera here. Section 103. Now, so here he's talking about, the question he's talking about in this section is, does the universal law of gravitation explain the tides or why things fall to the earth? And he says, I do not perceive that anything is signified besides the effect itself. For as to the manner of the action whereby it is produced, or the cause which produces it, these are not so much as aimed at. Right, so the universal law of gravitation, at least as Berkeley understands it, maybe not as Newton understands it, but anyway, as Berkeley understands it, the universal law of gravitation is one of these weak types of explanation. It just summarizes a big regularity about bodies under a lot of situations approaching each other, accelerating towards each other, although he doesn't say that. That's pretty important. But anyway, bodies approaching each other. So it just describes what happens, that bodies move towards each other. It doesn't so much as try, Berkeley is saying in that quote from section 103, it doesn't so much as try to explain why the bodies approach each other. So shouldn't we look for the better kind of explanation? And the answer, again, according to Berkeley, is there could be no such explanation. It's impossible. That is, at least, if by such an explanation you mean an explanation of one natural event by another natural event. Because all natural events are ideas. And ideas don't act. Ideas are inert. There's no necessary connection between ideas. Those are all kind of the same thing, right? That is, once you have one idea, nothing about it requires any other idea. So as long as we're looking for the explanation of natural events in nature itself, we'll never find it. Except in this weak sense that we can find the explanation, meaning we can arrange things into bigger and bigger like regularities that we've noticed. The things that already happened. I'm not talking yet about, I mean, of course, it's important to Berkeley that somehow we can use this to predict what's going to happen next, right? We started with that. That's the whole point of doing this, but we haven't really seen how that is possible according to Berkeley so far. So that's the empiricism piece of Berkeley. So the voluntarism piece is this. Well, okay, what is the cause then? What is the explanation in the strong sense? It's not another idea. It couldn't be another idea, so it couldn't be anything. It must be a spirit. So there is a strong way that this is going to be confusing. It's intrinsically confusing. I just used thing to mean these real ideas here. But of course, Berkeley also says that thing has this really broad sense in which it includes both ideas and spirits, includes everything. So let's say, there is something that explains the course of nature, explains all the regularities in nature and all the particular events in nature. But that thing is not a natural thing. It's not part of the world. It's not composed of sensible ideas. that thing is a spirit, namely it's the divine will. Um, Now, so notice, therefore, I think I've mentioned this before, but I'm going to mention it again, if so, that in a sense, Berkeley and Locke don't disagree about this, right? That these ideas of sense in my mind, those strong, regular ideas that don't depend on my will, um, are stand for something else, not stand for in the syntactic sense that there's a rule according to which something else of the same kind as them follows them or something like that, but stand for in the semantic sense they mean something else, and what they mean is the power that caused them. So what's the difference here then? Right? In other words, why does it make a difference whether I say that this power that caused them is a power in matter or that it's the divine will? I guess, I mean, um, maybe you think, well, obviously that makes a difference. There's all the difference in the world between, dead, unthinking matter, as Berkeley keeps calling it, and the divine will. But I mean, from this point of view, it's not actually that easy to see what the difference is. I mean, either way, what we know about this external cause is just that it's the cause of our ideas and the regularities between our ideas. So it might seem like the question of whether to call it God or whether to call it matter um, was not that important because its real name is the power that causes our ideas, whatever it is. So I think the difference here, so there is a big difference. The difference here is that Berkeley denies that this thing resembles our ideas in any way. Right? I mean, anyway, for sure that's true of Berkeley, right? He keeps emphasizing that not only can't our ideas themselves exist outside of a mind, but nothing that resembles them could exist outside a mind. So the thing that causes them must be something that doesn't resemble them. So if you think back to my explanation of why of how we can know that the external object resembles our ideas and what he means by that. You'll see again these things coming together. According to Locke, I didn't really leave room on the board to draw Locke here. Well, maybe I can kind of erase this stuff. Draw a little Locke up here. Right, so according to Berkeley, maybe I should make these like dotted lines or something. Right, according to Berkeley, these are observed regularities. I've seen that a certain kind of idea follows another one or is associated with another one in some way. So, of course, Locke thinks we have a lot of those too, But he also thinks there are certain visible necessary connections between distinct ideas. Like, for example, between the idea of solidity and the idea of figure or something like that. Those are distinct ideas, but there's a visible necessary connection between them. And each one of them stands for the power outside of the mind that causes it. And because this is visibly necessary, I conclude that there's a necessary relation between these powers. Right? So that's what I said. So resemblance here means analogy. It means this power is to this power as this idea is to this idea. So it doesn't, of course, tell me that there's something that kind of like looks like my idea, or in the case of solidity, I guess you'd say feels like my idea in the external thing. That doesn't make sense, right? Because when I ask what an external thing feels like, I'm asking what idea it causes in me. There isn't some other way of getting around to feel it directly. That doesn't make any sense, right? So when we say that these resemble these, we don't mean that they look like them or feel like them. We mean that there's an analogous structure to these, analogous to the structure of these. And again, because of this visible necessary connection, we can conclude that. Whereas, according to Berkeley, I mean, I kind of already showed you a quote where he says this, but this is worth emphasizing, especially before we go on to Hume. Section 106 of Part 1 on page 65. Again, he's talking about universal gravitation. And right before this, he said, it's not really universal. Some things go up. Plants grow up, whatever. It's perhaps not a very smart argument, but anyway, that's the argument. Okay, so Berkeley says, there is nothing necessary or essential in the case, but it depends entirely on the will of the governing spirit, who causes certain bodies to cleave together or tend towards each other according to various laws, whilst he keeps others at a fixed distance, and to some he gives a quite contrary tendency to fly asunder, just as he sees convenient. Right? So these things that, according to Locke, were supposed to be visibly necessary, Berkeley is saying we don't see any necessity at all. All we can say is whatever caused them must have wanted this regularity. Now, if you ask Berkeley, well, then hold on a second. Does that mean you think there can be solidity without figure? Without tangible figure? Of course, he'll say, no, that's absurd. Remember, that was another big part of the abstraction. That was a big part of the abstraction argument against Locke, or the argument against abstract ideas in Locke. That is Berkeley's argument against abstract ideas as they appear in Locke, right? So no, Berkeley will say, no, that's absurd. You can't take apart solidity and figure. But the reason is, he's going to say, because there aren't really two separate ideas there, right? They're inextricably bound up in the idea. That's why I can't abstract them from each other. They can't exist without each other. They're part of the same thing. So that's how Berkeley will explain a lot of the things that Locke explains our knowledge of this way. He'll say, yeah, we do have certain knowledge of that, Locke, but it's not because there's a visible necessary connection between distinct ideas. It's because there aren't distinct ideas here where you think there are, right? That is, there aren't two things that can be abstracted from each other where you think there are. That's mostly how he's gonna, well, I don't know, mostly, I don't know how to count how many, but anyway, that's a big way he's gonna try to explain it. However, in other cases, um, I think, and like, for example, that the interior angles of a triangle add up to 180 degrees. So this, again, at least on my understanding, was something that Locke explained our knowledge of by appealing to evident necessary connections between distinct ideas. I think he actually said that in book 4 about this example. Right? So what are the distinct ideas? Well, I mean, it's, something like the idea of this angle and the idea of this angle, or the idea of these three angles and the idea of these two angles. Um, or I mean, well, or both of those really. That's how the demonstration works. So those are the things that we can see necessary connections between. So what is Berkeley going to say in this case? So in this case, I think Berkeley is going to say this supposed universal law that the angles of a interior angles of a triangle must add up to two right angles is actually just an approximate empirical regularity. It's approximately true because of certain relationships that God has willed between ideas. But we don't see any necessity in it, and it's not exactly true. Berkeley's gonna, and this is, I will see more about why it's not exactly true. Basically, when I talk about the infinite divisibility of space and why Berkeley denies that. But you can see that if space is not infinitely divisible, then in a sense there is no such thing as a right angle. I mean, right, like if you take two radii that are both composed of the smallest possible thing, the minimum tangible, and suppose, I didn't count, but suppose they're both composed of n of it. And then you want to draw the arc of a circle that meets them both. Well, so the ratio between the length of this and the length of this is, so to speak, supposed to be pi over 4. Right? That is, according to regular geometry, it should be pi over 4, which is an irrational number. So there's no way that this arc can be composed of any integer number of the minimum tangibles. So you can't actually draw a 90-degree arc. It's actually impossible, according to Berkeley. All right. Anyway, so what this means is that the cause of our ideas, according to Berkeley, is a kind of simple, indivisible power in which we can't represent any structure, at least not by means of our ideas. We can't represent any structure that it has by means of our ideas. So it's what Locke calls a bare power. Or in other words, according to Berkeley, all our ideas are ideas of secondary qualities, which is pretty much what he says, when he criticizes the primary secondary quality distinction. Every one of our ideas stands for the power that causes our ideas, but as to using those ideas to like find an analogous structure in the thing that has that power, we can never do it. Um, right, and here's a place I think he relies on that. This is on page 78, section 137. Well, section 137 through 138. So beginning here. But perhaps you will say that though an idea cannot resemble a spirit in its thinking, acting, or subsisting by itself, yet it may in some other respects, and it is not necessary that an idea or image be in all respects like the original. Right, so that is what Locke would say, except he doesn't call this external thing a spirit, right? But Locke will say, of course, our ideas don't resemble external things in, for example, subsisting by themselves. Um, Rather, ideas can only subsist in a mind. Locke, will agree with Berkeley about that. But they resemble the powers of external things in some other way. Namely, there's this visible necessary connection between them and a similar connection there. So that's Berkeley is imagining someone trying to say that's how there can be an idea of a spirit, an idea that resembles a spirit. And I answer, if it does not in those mentioned, it is impossible it should represent it in any other thing. Do but leave out the power of willing, thinking, and perceiving ideas, and there remains nothing else wherein the idea can be like a spirit. For by the word spirit we mean only that which thinks, wills, and perceives. This and this alone constitutes the signification of that term. Right? Meaning, again, what we mean by the word spirit is just the power to cause ideas. And at least also to perceive. But in this context, it's just the power to cause ideas, namely the divine will. All we can represent about it using ideas is that it's their cause. Okay, are there questions about that so far? I didn't stop for questions for a long time there. Do people understand why it's not so easy to put your finger on the difference between Locke and Berkeley, and yet why I'm saying there is really an important difference? I mean, this is a good example of the kind of thing that that I'm going to ask you to do on the final paper. So it might be worth paying attention to what I did here, right? Like, it's a comparison between Locke and Berkeley, which it's a point about the relationship between Locke and Berkeley that can't be just taken apart into one thing about Locke and another thing about Berkeley, right? So that if this were a paper, I could split it into two papers, one about Locke and one about Berkeley. It's about this question: what really is the disagreement between Locke and Berkeley? So they're both needed to address that question. And moreover, it's about that in a way where the answer is not obvious. Some argument, first some argument needs to be made to show why it's not obvious, which is what I first did, and then some argument needs to be made to show what I think the answer is, which is what I did next. So I say, It's not obvious exactly what the difference is here because, after all, they both agree that call this what you will. What it is the power to cause our ideas and their regularities. So maybe they don't disagree about anything. Um, and then I said, well, no, they disagree about whether this resembles our ideas. And then to know what that means, you have to look at what Locke thinks it means. And then you can look back at Berkeley and see that's exactly where he disagrees with Locke about this. Okay. So it's like something surprising about the relationship between the two and therefore worth writing a paper about, for example. Interesting, at least to those of us who are interested in such things. um, uh, all right. So, by the way, my daughter Margaret, after the last lecture, or no, it was the one before last, and she asked a question about the snowball. What is Berkeley's argument against Locke's idea of a necessary connection between ideas? He doesn't exactly have an argument against it. He just says there evidently is no such thing. He probably it's a good question actually. He I don't think he thinks. I'm pretty sure he doesn't mean by that. So far, we just haven't seen something like that, but maybe tomorrow we will, or something like that, or maybe you see it and I don't. Although these empiricists will often say something like that, right? Like if anyone has an idea of this necessary connection, I can't argue with them, but I don't have it, right? But usually they mean that kind of ironically, like they don't really believe that anyone has it. And I think, that comes out in Berkeley when he talks about someone claiming that we could perceive matter if we had another sense, or that we well, this applies both to matter and to spirit, that we could perceive matter, or that we could have an idea of spirit if we had another sense. And he says another sense could only deliver more ideas, and they would have to be just as inert as the ideas we have. So that is, he appears to think it's absurd that the objects that are perceived by a mind could be perceived as necessarily connected to each other. But he doesn't say why. You can kind of imagine why. Well, it may be harder for Berkeley than it is for Hume, actually. It must have something to do with what it means to perceive something. But I can't tell you exactly how Berkeley would fill that in. I could try to tell you how Hume would fill that in or how Kant would fill that in, which I think they're similar to each other. But how Berkeley, I'm not sure. All right. So that was a really good question. Okay. So, having said all of this, what does that leave us with in terms of natural science and geometry and mathematics? Well, it means that the regularities we have observed so far we have to regard as arbitrary, or like in the literal sense of arbitrary. They depend on the divine choice, arbitrum, right? So we have to regard these rules as arbitrary. But I think Berkeley believes that we do know something about God because there are such rules. Because even though we can't predict exactly which rules will continue to hold in the future, we know that some rules, we've relied on them in the past to our advantage, right? So we relied, these regularities were kept up in a way that's useful to us. That is, that caused us, that brought us pleasure. Didn't it cause us? Because we relied on them. That is, so when I say because we relied on them, now we're talking not about something that happened in our ideas, but something that happened in our will, right? So our will's past reliance on these things to its own gratification because we got pleasure or didn't get pain is a sign of a certain conformity between this will and this will. So as at least as far as it goes, it shows that God is good, right? That is, it shows that this will is on our side. It's on the side of finite wills. Now, how far you can go with that, it's not clear. There's obviously a lot of things that happen in the world that are not gratifying to our will. A lot of unpleasant surprises. um, so, so Berkeley is faced with a version of the problem of evil, natural evil in particular, as we're talking about here. That is things that happen, bad things that happen to us, not through our own will, but because of nature, which means because of the divine will. So, Berkeley gives some pretty traditional answers to that question. That the main one being that what looks bad from a limited perspective, actually, when you look at the whole train of ideas in all the finite minds put together, you'll see that that was necessary for important purposes. So, although it seemed bad, it was really good. So this is the kind of thing that everyone, Descartes, Leibniz, but I mean, pre-modern people too, it's an old type of response. But if we did read the Dialogues Concerning Natural Religion, we'd see Hume pointing out that for an empiricist, that response is kind of problematic because all you have to go on is the regularities, the good regularities you've actually observed. So even if you could reconcile that somehow with a perfectly good will, you don't have any evidence for the perfectly good will. You just have a logical possibility of reconciling the two. All right, like what Berkeley would say to that, like how Berkeley would come back against that, I'm not sure, but I just want to point that out. So in any case, so that means that one purpose of natural science and mathematics, according to Berkeley, the theoretical purpose of it, so to speak, that is the purpose of it when we're just using it to contemplate what is or what has been, the purpose of it from that point of view is to appreciate God's goodness. That's its usefulness. What about its practical use, right? That we rely on these regularities to continue, even though we have no proof that they'll continue. So, I mean, what that means, it's another kind of relationship between our will and the divine will. But in this case, the relationship is faith. And again, it's faith in the sense of trust. In a sense, it's the same kind of trust that Locke was talking about, trust that someone is telling the truth, right? That is, We trust that God hasn't set up regularities in order to mislead us. Therefore, even if the regularities fail, uh, God, so to speak, wanted us to rely on them. So that will be the best thing to do in the end, even though there will be some unpleasant surprises along the way, right? So the two uses of natural science and mathematics are, number one, as far as the purely theoretical use of it goes, to survey the things we've already observed that have already happened and use them to appreciate the goodness of their cause. And number two, the practical use of natural science and mathematics is to use them as signs of what we ought to trust in or have faith in. That is, namely, certain regularities that we've um, uh, correctly come to rely on, I guess, in a practical sense of correct. We have sufficient evidence that of that regularity that the best advice would be to rely on it. And Locke says that any purported use of natural science that goes beyond those two is thinking that amounts to thinking that the important thing is these regularities. So that is, it amounts to focusing on the syntax of the world rather than its semantics, right? So it's like spinning out all kinds of things that would happen or might have happened, assuming this regularity always holds, but without any attention to what the regularity actually means, which would tell me where it's applicable and where I ought to be applying it and where it's like has nothing to do with me and I shouldn't be trying to apply it. Right, so this is on page 66, section 109. As in reading other books, a wise man, as in reading other books, a wise man will choose to fix his thoughts on the sense and apply it to use, rather than lay them out in grammatical remarks on the language. So, I mean, you might gather that although this looks like kind of a striking confirmation of my thing about syntax versus semantics, I started thinking that because of reading passages like this, right? It's not like, oh, what a pleasant surprise. All right, anyway. Okay, so as in reading other books, a wise man will choose to fix his thoughts on the sense and apply it to use, rather than lay them out in grammatical remarks on the language. So, in perusing the volume of nature, it seems beneath the dignity of the mind to affect an exactness in reducing each particular phenomenon to general rules, or showing how it follows from them. We should propose to ourselves nobler views, such as to recreate and exalt the mind with a prospect of the beauty, order, extent, and variety of natural things, hence, by proper inferences, to enlarge our notions of the grandeur, wisdom, and beneficence of the Creator. And lastly, to make the several parts of the creation, so far as in us lies, subservient to the ends they were designed for, God's glory, and the sustentation and comfort of ourselves. Oops, I'm off the page. And the sustentation and comfort of ourselves and fellow creatures. Right? So those are those two uses I was just talking about. And he says something similar about mathematics somewhere else, but I won't read that. And anything beyond that is just playing around with symbols. Okay, so I just finished the first thing I wanted to talk about. There's two more. Are there questions before I go on to the infinite divisibility of space? Okay, so I'm going to erase this. So what Berkeley claims about mathematics, now, I mean, of course, he doesn't want to say mathematics is just a bunch of BS, right? I mean, because it evidently is not. We use it for all kinds of stuff. Um, so there clearly is something to it. Using mathematics, someone can put some apples in a bag, and then someone else can put some more apples in the bag, and you can predict how many apples will come out of the bag when you empty it. It's very useful. It seems like there must be really something to it if it has those kind of conclusions. So Berkeley does not want to deny that there's any truth to mathematics, but what he does want to say, and when I say he doesn't want to deny there's any truth to it, meaning he doesn't want to deny that there's any truth to its axioms or theorems, and he doesn't want to deny that there's anything right about its method. Is the no infinite divisibility thing for the same reason he thinks numbers are relative? Someone just asked. It isn't obviously for the same reason, but maybe it really is for the same reason if you think enough. I'm not sure. Maybe after I talk about what the reason is, you can decide whether you think it's the same reason. Same reason. It's a good question, actually, but I'm not sure. All right. Anyway, what was I saying? Oh, right. So he doesn't want to deny that there's a certain kind of truth to the axioms and theorems of mathematics, and a certain amount of correctness to the method. After all, the method is how we got from the axioms to the theorems. So if there's some truth in the theorems, it seems like it couldn't be a coincidence. There must be something correct about the method. So he says that actually mathematical axioms and mathematical demonstrations are fine. Now, I mean, our fine is going to be subject to a certain qualification, as you could see from the drastic consequences I already derived, right? Like there can't be a quarter of a circle. That's, you can pretty easily prove from Euclid's axiom that there are axioms that there are quarters of circles. So, right. So the qualification is going to be there's nothing, they're fine as long as you recognize that they're only approximations. But as long as you do that, they're fine. So it's not so mathematicians, he's saying, if you say like the last person I'd expect to make a stupid blunder about what's true or what follows from what is a mathematician, they're so rigorous and focused and whatever, Berkeley says, sure enough, while they're thinking about mathematics, they are very rigorous and precise and everything. The problem is, and I'll show this to you in the text. This is on page 70, section 118. Mathematicians, though they deduce their theorems from a great height of evidence, yet their first principles are limited by the consideration of quantity. Right, so he's thinking the two branches of mathematics as they existed then and for quite a while after this were arithmetic and geometry. They're both about two different kinds of quantity. That's how people think about what mathematics is. Yet their first principles are limited by the consideration of quantity, and they do not ascend into any inquiry concerning those transcendental maxims which influence all the particular sciences. So, right, what he means by transcendental here is, roughly speaking, that it pertains not to a specific kind of things, but to everything in general. So, and what he's saying is that mathematicians focused all their rigor and precision on first principles about quantity, like the whole is greater than the parts. That's one of Euclid's axioms. That's why it keeps coming up. And on the correctness of deduction starting from those first principles about quantity. But there's higher first principles that don't fall under the scope of mathematics, and mathematicians therefore don't look into them any more than other people do. And in that respect, Berkeley says mathematicians have made the same errors as everyone else. And of course, the errors are, number one, they believe in the existence, or at least possible existence, of things that resemble their ideas outside the mind, and in the possibility of abstract ideas, in particular of abstracting certain primary qualities from each other. Shape from size, length from width and depth, other things like that, right? And the infinite divisibility, or the supposed infinite divisibility of finite extensions, according to Berkeley, somehow gets into mathematics, slips into mathematics as a metaphysical presupposition that has come to seem reasonable because of those mistakes about the higher pre-mathematical principles. Now, he doesn't explain exactly how that happens, although he gives some indications of what's involved. I mean, one thing, anyway, one point about it is that Berkeley says, well, we evidently can't see or feel anything smaller than a certain smallest, the minimum visible or the minimum tangible. Hume is going to make a big deal about this too, right? That is, as a point gets smaller and smaller and smaller, you see it smaller and smaller and smaller, and then at some point you don't see it anymore. And you never see anything smaller than that last one that you saw. So if you realize that those ideas are all there is to extension, then what you say is, so there's no extension smaller than that. But if you think that those ideas stand for something outside the mind, then you can start to think that even though I can't form an idea of something smaller than that, there actually is something smaller than that out here, and I can't imagine or see it because it's too small. Right? So once you get rid of this, you get rid of that source of error, which at least is part of what makes it plausible that extension is infinitely divisible, according to Berkeley. Right? That is, Berkeley says that if we really just focused on the ideas we have in our mind, it would be obvious, self-evident, that a finite idea can't consist of an infinite number of parts. We have a finite idea. We have it by having a bunch of these smallest possible ideas next to each other, whatever that means exactly. And that's all there is to it. So it's only by supposing this mysterious and actually impossible external substance that we get ourselves to somehow swallow the absurdity of a finite thing with infinitely many parts. Um, now, so therefore, Berkeley says that mathematicians are enabled to believe this by this metaphysical error, um, and even though they never state it explicitly as an assumption in their system, it works its way into everything. Now, when you say they don't, when he says that they don't, I'm not going to show this to you in the text, but he says this is in section 123 on page 72. It is not expressly laid down either as an axiom or theorem in the elements of that science. The elements of that science, meaning um, uh, the topic of the subject matter of the book called Euclid's Elements. um, it's about the elements of geometry. So anyway, so he's saying there is no axiom or theorem in Euclid's system or other similar systems of geometry that claims this infinite divisibility. Now, on the surface, that's not true at all because, like, for example, you can prove. Now, I didn't draw this. Suppose these sides both, well, actually, I mean, that doesn't really matter. Suppose these sides both have the same length, A, right? You can prove that this length here, this is a right angle, is not in any integer ratio to A, right? So if we call this B, there are no natural numbers, like 1, 2, 3, whatever, m and n, such that m over n equals a over b. I mean, right, in particular, b is what we would call the square root of 2, which is an irrational number, and saying it's an irrational number is just the same as saying that it's not equal, or sorry, b over a is the square root of 2. So a over b is 1 over the square root, right, whatever. Anyway, so saying that it's an irrational number is just saying that it's not equal to any rational number like that, right? So if you can prove that, then by the same type of argument I was making before, you can show that there can't be a smallest part of extension, because if this consisted of some integer number of those smallest parts, this couldn't also consist of it. And so that is a theorem in Euclid, that this is irrational, and therefore, actually, does Euclid prove that? Anyway, you can prove that from Euclid's axioms, that this is irrational. That's enough to show that there is no smallest part of extension, i.e. that it's infinitely divisible. But I think Berkeley's position about this is that if you understand the axioms correctly, you'll see that the theorem that's proved there is not really that, b squared equals 2a squared, which is what has this consequence. So what we show is not really that b squared equals 2a squared, this special case of the Pythagorean theorem here. What we show is that the bigger you make a, the closer you'll get to this being true. Assuming that the axiom is that the axioms are true in the same sense. Um, so, and the reason I think that's what he thinks it means is because has to do with his explanation of why geometers always keep wanting to think this absurd thing that extension is infinitely divisible. They want to think it because the way geometry works is that I use some particular finite extension and I make it into a general sign of infinitely many other possible extensions. So in this case, when I do this proof and I call this length A, that is, I don't give it a number. So I'm using it to stand for any possible size triangle. When I do that, even though this one, let's say, has only 100 parts, right? Berkeley says there is no such thing as the 10,000th part of an inch, right? So we don't know exactly how big the smallest part is, but it's bigger than that, right? There's less than 10,000 of them in an inch. So let's say this has exactly 100 parts. I'm using it as a general sign to stand for other lines that have a lot more parts. So as I do the proof, I can't at any point, that is, I have to have set up my rules such that I don't at any point rely on the fact that it only has 100 parts. It only has 100 parts, but if I started using that in my proof, it would apply only to a triangle of this size and not to bigger triangles, right? So, so everything I do with these general signs is with a view to keeping in mind how things will change as I make the line bigger and bigger and bigger, and therefore it has more and more parts. And so when we get conclusions like this, I think, according to Berkeley, what we've concluded is that, so to speak, this would hold precisely at the time when the line became infinitely big. Or, to put it in a way that both we and Berkeley would find more intelligible, the bigger you get, the closer it becomes to being true. But it's never exactly true. It can't ever be exactly true, according to Berkeley, because, as I said, there can't be, if there's one smallest part of extension, there's no way you can have a certain number of them and another number of them and have this relationship hold. Because that would have to mean that the square root of 2 is rational, and you can prove it isn't. So Berkeley says, but don't be upset about this, mathematicians, because actually this will make your science easier and will have no effect on its legitimate applications, which, as I said, are to notice the regularity that God has established and to rely on regularities for practical purposes. Of course, we never either notice that this exactly holds or rely on it exactly holding, because all our measurements are only good up to some limit. So all our measurements always give rational answers. We never measure something as exactly the square root of 2 longer than something else. So what we were relying on was actually always the approximate one, which is the one that he thought we proved. So he says that will have no effect on the usefulness of mathematics, and meanwhile it will make it much easier because all kinds of weird questions that you get into because of this infinite divisibility won't come up. Now, I think that definitely shows a certain lack of experience in geometry on Berkeley's, at least I feel like it does, on Berkeley's side, because if you really work with geometry even a little bit, you would realize that geometry will not become easier if it turns out that this is not exactly true. It'll become much harder, right? And similarly, like I was saying, the relationship between angles. So, like, you know, um, you no longer be able to say that there's some fixed ratio between the length of the arc and the length of the radius. It will depend on exactly how those smallest pieces line up and exactly how many of them fit in here or whatever. Um, so actually, I think it would be a nightmare for geometry, but Berkeley, it's similar to, I don't know if this is true, but I guess I've heard that at one point some state legislature in some state or other passed a law saying that from now on pi would be equal 3 because that would make geometry much easier if people didn't have to learn this weird number 3.1415. So it's like from now on pi will equal 3, but actually if you took pi to be 3, geometry would become very difficult. um, but in any case, that's Berkeley's view. I think his views about arithmetic are related to that, but I don't have time to get into them, and I'm still not sure what the answer to Sean Park's question about whether it's the same thing or not. Because I need to stop this and say just a little bit about the refutation of skepticism. And what I'm going to say about it, so skepticism here means skepticism about the external world. Right? So Berkeley takes it that the position of the skeptic is that I'm sure that I have these ideas in my mind. I guess I didn't have to erase that picture. I'm sure that I have these ideas in my mind, but I doubt whether there's anything outside my mind that corresponds to them. And Berkeley says, for me, that doubt can't come up because I already denied that there's anything outside the mind that that corresponds to them. So the skepticism is refuted. Now, there's a lot of things you could say about that. Um, like on the face of it, it seems, and a lot of people say this about Berkeley. A lot of later people, even in like the British empiricist school, broadly speaking, say just this about Berkeley. He may have thought that he refuted skepticism, but obviously he actually is a skeptic, right? Because this is exactly what the skeptic claims, that these things out here are not there. Well, actually, the skeptic claims it's doubtful, but this is worse, I guess, right? So, but without getting into the question of like what's to be said about that, I want to point out one thing in the next 2 minutes about this, which is that if you look in Descartes' first meditation, and it's basically Cartesian skepticism, or a piece of Cartesian skepticism about the senses. Actually, it doesn't map up very well to what Descartes actually doubts in the first meditation, in the order he does it. But without getting into that, I'll just say it's a kind of Cartesian skepticism about the reliability of the senses is what he's aimed at here. So how does Descartes show in the first meditation, like throw doubt on the reliability of the senses? Well, the meditator says, well, I know at least that everything I see is the way I see it. And then the response is, I mean, this example comes up a little later, but it's the same, it's the type of example they're thinking about there. That, I saw this tower when I saw it in the distance, it looked round, but when I got closer, it looked square. These two are inconsistent with each other. It can't be both round and square. Therefore, at least once my senses have deceived me. Right? And therefore I should never rely on them entirely. That's the skeptical argument there. So what does Berkeley say about this? Well, so according to Berkeley, it's not really true that this tower being round and this tower being square are inconsistent with each other. These are two different ideas that were in my mind at two different times. A small round idea first, and then later a big square idea. There's no inconsistency. So, in a sense, it's looking good for Berkeley because he can say, see, there's no ground for my senses were completely reliable. What I saw was there. What I saw then was there then, and what I see now is here now, and I was right both times. But the problem comes when you ask, like, what it means to believe that the tower is really there. Is it to believe that there's just this small round idea in my mind right now? Well, if I walked towards the tower, instead of it looking square, it kind of like faded away. I would say there wasn't really a tower there. Right? Or if when I got there, it still looked round and it still looked fine, but I put my hand out to touch it and my hand went right through it. I would say, oh, there wasn't really a tower there. It was some kind of illusion, mirage, hologram, something, right? So when we say the tower exists, what Berkeley has to agree we mean by that, I think, is not just that this is here now or that this is here now, but that certain regularities hold. That if I have this idea and then I do certain things, I'll have this idea. All of that is necessary to claim that the tower actually exists. And according to Berkeley, once again, we have no demonstrative proof that those regularities will continue to hold in the future at all. So it turns out that as far as what we usually mean by saying that things in nature exist, Berkeley is in exactly the same boat as Descartes, I think. He hasn't refuted it because he hasn't shown demonstrative evidence that the regularities hold that would need to hold for that belief to be count as true. Okay, sorry, I know I went over 2 minutes. I will see you next week.